Number 39, we're going to prove the following identity. 2 tangent x secant x equals 1 over 1 minus sine x minus 1 over 1 plus sine x. To verify an identity, we treat each side independent, and we label this side the left-hand side and this side the right-hand side. So we want to write everything in sines and cosines first off. So we're going to start with the left-hand side. Our fundamental identities tell us that tangent is sine of x over cosine of x, and the secant is 1 over cosine of x. So now we put these together by multiplying it across to get 2 sine x all over cosine squared x. That's all we need to do for this side for now. We're going to switch over now to the right-hand side. Our goal is to make the right-hand side look just like the left-hand side. So we're encountering these two fractions, and what we need to do is get a common denominator. So in order to do that, we're just going to put the denominators on each so that they have the same denominator in both top and bottom. So for this one, I'm going to put a 1 minus sine x in the denominator, and at the same time multiply it in the numerator. Then over here, I'm going to put a 1 plus sine x on the bottom and on the top. That results in a common denominator for both fractions. Now that these have the same denominators, we can bring the numerators together. Paying close attention to the negative sign that's in the middle, because it applies to both terms that we are subtracting in that numerator. So it's going to turn into 1 plus sine minus 1, and then negative negative turns this one into plus sine x. Okay, and now we're going to simplify the numerator. The negative and the positive ones will cancel, and then we have two sines added together to give us 2 sine x. Okay, and it looks something like this right here. Now we need to multiply out the denominator. The pattern to this would be like if we were to multiply 1 minus a times 1 plus a. We're going to have the 1 and the a, and it turns out to be 1 minus a squared. So the same pattern is here with the sine of x. Underneath, when those two binomials multiply, it'll be the 1 and the sine squared, and then it's going to be subtracted. 1 minus sine squared x is how the two will multiply together. And then from our fundamental identities, we know that 1 minus sine squared x is equal to cosine squared x. So we're going to change this to be 2 sine x all over cosine squared x. And we'll notice that that's exactly what we had on the left-hand side a second ago. So now we've made the left-hand side and the right-hand side look the same. And that would be verifying the identity.